The universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light. And I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. Fields and forms, math and voids. It all seems with one voice. It's boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars. And I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hello there, everybody. How you doing? It is I, Mark D'Antonio, with our good buddy Daryl Mason. Hello, Daryl. How you doing?
Hello, Mark. I'm good, thanks. How are you? Hello, everybody.
I am doing just fine. So everything good at your end, Daryl?
Weather's changing. The season's changing.
Yeah.
Highs have been in the 70s. It was only in the 50s today.
Okay.
And it's going to continue for a few days. And I gather it's snowing a lot up in the high country.
Yeah, it probably is, huh?
Yeah.
Well,
the leaves are changing, and everybody loves it when they get turning aspen leaves and snow on the mountains at the same time. So everybody's going camera crazy this year. It's been a good leaf peeping season.
Yeah, I was going to say the leaf peepers. Leaf peepers are out in force. Now, I heard something that said that we were going to end up with a relatively benign relatively benign winter. Is that true, I wonder?
I think it depends on where you are.
Yeah, I guess so, huh?
Uh, El Nino or whatever it is, everybody's going on about. I think it can have wildly different results depending on where you are in the country.
I think you're right. Hey guys, we're just doing our finished setup here, and so I'm going to try and get one more look at the lagoon before it's gone for the season. Let's see if we can see it. It's actually pretty low now in the sky, and that's not exciting, but it is what it is.
Yeah, time marches on.
It does indeed.
And the stars of summer and winter are coming to the fore.
Yep. Well, we can see it. That's good. And it's still well above the wall of the observatory. So we'll check it out. I had Daryl on with me earlier when we actually focused. So we have good focus right now. And we're going to move this over right there. We're actually going to... I think we'll leave it right here. Because this is good. All right, let's see now.
You ought to sync on that.
Well, we are plate solved, remember, in this whole region. But actually, let's just do this. Let's confirm.
Well, as you said, a star might be better. So
Yeah. I plate solved on a whole bunch of stars, so you might have some induced error. I'm not sure. Okay, so here's the lagoon. And right now it says 1804.35 for our right ascension. And it says 24:35:04. So what is the actual on day 18:05:03 and minus 24:22. So it's actually quite close. So I think we're good right here. I don't have to sync. Our plate solve was just fine. Which is a good thing. All right, now we're only gonna if when Cosmic Ray joins us, if he joins us, let's all remind him we now have a spider web in the building right there. So that's Cosmic Ray's spider that he likes to see.
Tell him you named it Ray.
Yeah, we have a spider named Ray in there. Hello, Renee Behrens. How are you? I want to say hi to Michael Hedrick, Tim F. Woo! Tim was first. Nice to see you, brother. And then, of course, Simon Thompson's with us. Good to see you, Simon. And Michael Galea. How are you, man? Anything new you're checking out from your end? Yeah, so let's first... there's some wind out there tonight, as you can see, with our with our little flag there, our little weather meter there. I am getting a weather station for the building, so we will have a weather station to tell us what's going on and give us an idea of what the wind is like at the building. That's important. And if it's above 15 knots, we're not going to open the building anymore. And the reason is because we're going to have two telescopes out there, one in this building and then one several miles westward into even darker sky. And we're going to end up taking that telescope, and it's going to be in that clamshell we're making, which is going to open up and expose the entire telescope to all the way into the horizon. This way we can see things like Omega Centauri, which is about 16 degrees above the horizon at highest, and it's the biggest globular cluster in the sky, and the most phenomenal. And we've been aching to see it, and we'll be able to see some things. Now, looking at the low end of the horizon is never any good, right? It's not that good, and we know that. But we're going to give it a shot, because it's better to be able to see it, even if it's not perfect. Because, again, we're about astronomy outreach. That's what I do. Us astronomers, we like to wear flannel shirts. Actually, when it's cold.
Yeah, I'm wearing mine right now.
Yeah. Hello, Alicia.
Blue and black checkers.
Alicia Vieras is here with us. Nice to see you. Yeah, and let's see. Robin Curtis is also here. Hello, Robin. Robin's made an interesting development. We're actually scrubbing data in the database right now, and that's... Well, I have to admit something. Okay, I put it on the back burner for a while because I got so involved with other things, the other building, the other telescope, the other system, what camera we're using, etc., which I'll tell you all about in a minute. And I put the data on the other end of the spectrum, and Robin reinvigorated me tonight by talking to me about it, and she sent me a database that you can search. Now, the data is not clean yet. I'm going to clean the data with her, and we're going to get it all cleaned up, and then we're going to make that publicly available, once we clean the data, all right? And, for instance, when you can do, you just hit Control-F, like you do in a browser, to search, and what you end up seeing is, for instance, if you put in Orion Nebula, you get all the times that we photographed the Orion Nebula, and there's images in the database as well. So you click on the image, and you go to the OneDrive, and it pulls up that exact file. So you can actually go and look and explore, and it's read-only, of course. You can't change anything. But that's coming, and eventually we'll have a front end that's a little more polished, and so it's going to be pretty cool, I believe. So, Michael Glee is watching us at work. Don't tell anybody, Michael. Come on. Don't get in trouble. Okay, we are stably guiding here, and I'm giving it a shot. I know that it's going to not be perfect, but you know what? Let's see if a 25-second shot will actually work here. Now, I put 25S for 25 seconds up here, but I could easily have just said 25,000 milliseconds. All right. In fact, if I do that, then I can do it all on my keypad. So 25,000 milliseconds is 25 seconds because there's 1,000 milliseconds, milli, being 1,000 prefix, in a second. So there we go. And that we're going to take off and run with right now. Our gain is set to 150, which is about 50 higher than the camera's optimum setting. So we're going to come out of our night vision mode and go into our adaptive stack mode. And we'll be able to see right here, you'll see what we're doing. You'll see the numbers stacked. Okay. You'll see the total exposures, total minutes, basically. The first one, obviously, is going to be for just 25 seconds. All right. And over there on the right, way over here, this is the progress bar. When that thing hits the right end, we get this filling, bam, and then bam. Look at that. So this is the beautiful Lagoon Nebula. Look at that. I'm telling you, I can't get over how much better this camera is. It really has proven its worth to me. These little tiny globules in here are more than ever visible. All right. So it's really something. I'm very impressed. Yeah, looks good. Look at that. Wow. So this is a stellar nursery powered by a star that's right there. See how bright that is right there? That is a O-type star. And we know that we have O, B, A, F, G, K, and M. And in astronomy, you can read it in some books. It says you can remember it by saying O, B, A, fine girl, kiss me, or O, B, A, fine guy, depending who you are. And so the O, B, A, F, G, K, M, if you don't know how to remember it, it's O, B, a fine guy or girl, kiss me. And when you in astronomy, we don't use that for real, but I'm just saying that's what we do for kids and so forth to remember, teenagers and so forth. When I taught astronomy at schools and in university, I would use that moniker. People would always snicker, but it's actually something memorable that you can remember.
It's a mnemonic.
It's a mnemonic. That's correct. Yep, that's exactly right. Hello, Kathy Pernisek. How are you? It's so nice to see you. Yeah, so we're going to let this come in. We've done 5 exposures. You can see right there, 5 exposures. And they've been stacked. And to remind you what a stack is again, we take a picture, take a second picture, align it with the first, get the stars all lined up, and lay it down on top of the other one. and we do an image sandwich that way, so that all the data ends up coming to the top. All the dark data, even the darkest little things like this right here, come to the top. You know, in fact, let's close in on that little guy. That's pretty interesting looking. Our stars are a little bit elongated because we have some wind out there right now. And if I just, there's two things that's really bad right there, that one. There's two things that are going to happen. We're in the process of getting a whole nother terabyte of storage. And when we do, then what I'm going to do is I'm going to hit over here where it says raw frames. I'm going to say in here, I'm going to drop down this list and say save all. And that way I'm going to get the individual files. And that way the stack that we make automatically in this program may have some elongated stars. However, I will be able to take them later and make them, exclude the ones that are, ruined, like these guys that made up this stack, and only use the better shots, only use the perfect shots, and then make a new stack. So if we stack 20 shots, we might only use 12 or 15. If it's a windy night, we might only use 7 or 8. But this is the idea. So I got approval to I got to get approval to do that, get the extra terabyte of vapor storage out there on the cloud, and if we do, then we'll be able to do it. I'm sure we'll get the permission. All right.
Kathy wants you to say hi to her.
Who does?
Kathy Pernasek?
Kathy, I said hi to you. I said hello, Kathy. I'm fine.
Hello, Kathy.
Oh, maybe she was just saying, I'm fine, Mark, and you, because I already had said something to her, see?
Oh.
Yeah. Vince Giglio, how are you? I must sacrifice a new telescope to the weather gods. ERRT Radio, hi there, Ronald. Ronald is with us. How are you? Good to see you. Ronald, you have a session with us that you have won. You get to come on with us and decide what you're going to do. And people are going, well, how do I get to do that? Well, Ronald is he's in our Patreon, and he actually, if you look at the levels in the Patreon, he's in at the highest level. So he gets us once a month for a personal sky tour that will be streamed. Everybody will see it. All right, I'm going to clear this and let it start again because this is not doing very well in terms of the... Yeah, that's... Look at the beauty here. These are stunning. Okay. Let's move this down just to try and mitigate. Yeah, see that? See the hourglass in there? The O-star is there, and that O-star is powering this whole nebula. O-stars give off most of their radiation in the ultraviolet, which is the high-end blue, high frequency, And you can see our spider web up there, which we're going to name the spider Ray after Cosmic Ray, who's always talking about our spider. Matt Armitage, how are you? Welcome. Hopefully, for those of you that aren't subscribed, please do subscribe. Sam S. says ZWO should use your images to sell scopes. Well, they make cameras that we use. And right now it's not still out there, so we're having a problem. It might actually be better, I'm zeroing that out. Might be better if we try not looking this way, if we actually head up to a different spot in the sky. All right, let's see how this works. Now, one thing I'm going to try is this. All right, I'm going to do this. And now, okay, and we'll pause this. Let's see if we, what we got here. Yep, see that wind is really going crazy. So we'll try again. Our numbers here tell us what the wind is doing. If they get up past, like, see it's 2.6, that goes to 0.5, that's fine. But if it goes to 2.6, 2.9, 3.3, 5.6, 7.5, then I can just pause the stack, okay, and not capture. So if I'm watching these numbers now, if these just stay fine, then we're going to be okay. But if there's too much wind, they lose their position. And we don't want that. All right, let's see where this goes now. Okay, so you watch the numbers here, and you see that if they end up going too high, like that was too high, that one went up to 6.5. So I'm skipping that exposure by hitting pause over here, right there. Then I'll hit resume. So we have 2 good exposures right now. All right, so that one's been ignored. And once we get another one, we'll hit resume for the moment and watch our numbers. I can tell you, when I was doing this professionally in observatory, this was, see, 3.8, can't use it. 4.1, 4.4, we're getting a lot of wind. But it won't affect us. But check out that beautiful central area. I actually can enhance that. If we do this, it'll be really blatant. Okay, see how the sharpening works? Look at that. I'm going to drop it down just a little. I'll drop it down to 2.5 or so. Looks really nice. Okay. All right. Yeah, 3.94. No good. So I've told you guys before how this dark nebula, this is really where it's at, man. The universe, the devil is in the darkness. You know, the life comes from the dark. The dark nebula is where the seed of life begins. You know, so it's really interesting to do this and take these pictures. Now, once we get our database going, you can search for every single image we've ever done of the lagoon, and then you could do comparisons to see if by chance anything's changed. That some stars get brighter and some stars get dimmer. It's something that could have happened, you know. So you get a chance to do real astronomy with our stuff too, so that's nice. And that's because we keep a database of it, and you can always go back to anywhere. All right, let's see here. Let me back out just to show you here. And we're going to move on to another object that's a little higher up in elevation, might give us a better shot. What you're seeing here is basically a lot of dark dust. This is not a void, okay? This is dust and gas, and this hot O star and other young cluster stars in here that are forming in this stellar nursery are actually being quite young, and they ionize the hydrogen gas in here and make it visible. So it's almost like it's a little area amid the darkness that's being illuminated by causing these little hydrogen atoms and others to ionize and glow.
Say hi to Vera, Mark.
Vera's with us?
She is.
Oh, I didn't see her. Oh, Vera Lucia Campos. Hey, how are you? How are you doing, Vera? Vera's one of our biggest allies. She's been with us for a long time. Okay. Yeah. All right, you know what? Even though it's not all that it's cracked up to be at this point, I am going to save it. And this is only 3 frames. And I ignored 8, so that's okay. So we'll just save it, and you'll see the green bar saying it's been saved. But the frames I did save are nicely guided. You know, I did it kind of in between the wind. All right. Okay. Now we can get out of this and come back to our 1 second exposures. Now, for anyone that does join our Patreon and wants to go on a personal guided tour, keep in mind that when you do that, you may not know what you want to see, and we'll certainly help you if you kind of know what you'd like. But the benefit is that after we capture some objects for you, we are going to fully process them and make them available to you. So you won't just get the raw ones that you see up in the database now. Okay, you can get fully processed ones that we've put all this time into to process, and that's something that's one of the big draws, I think, for all of this. Okay, so let's go into here for real now. Okay, we're way low to the horizon, and as soon as the sun sets in the desert, we get winds that come along, desert winds. So let's move up here. Oh yeah. This is a keel of the eagle. Okay, you can tell by the eagle right there. Yep. Vulpecula, the fox. And right down by a Vulpecula's foot is the Dumbbell Nebula. That's a really cool nebula, really pretty, so we'll check that one out tonight. Alright, so I told the telescope to head up there, and there it goes. Yep. Alright. Okay. Alright. Alright, so we should... It's right there. I'm going to move it in and bring it in. Excuse me.
I think Ronald has a question for you.
Okay. What you got, Ronald? Oh, wait a minute. I know what I did. Sorry. I gotta do this. Now it'll move over. I had slowed it way down. My apologies. What did he ask?
He says, I have my first 3 objects. I think they were available this time of year. Then he says, and how many objects do I get for my session? Question mark.
As many as we can fit in, and as many as the weather allows. And not to worry, because if you're going to be doing that kind of Patreon, you get a session a month, Ronald. So we will make sure that you're fully covered. Now, we can't do 30 objects, but we can probably do a solid 4 or 5 for you. Okay, so let's move a little bit west here, center it up. I gotta actually drop it down to center it up. It's an illusion. There we go. So I just have to basically go a slight bit north. Okay, there we are. And now I come in here and get rid of that. Center. Zoom. And synchronize. All right. When I go out there in November, I will also be doing a full realignment of everything so that we don't have to worry about doing a lot of synchronizing. Okay. Now let's just watch this for a minute and see how it looks. Make sure that we get... let's go to 50%. Yeah, we're still getting some wind. Okay. Yeah, still getting wind. It's bouncing the scope around. And...
See the apple core, folks?
yeah. Yeah, they see it, don't they? Okay. Vera Lucia says, I remember you dreaming about having a telescope in Arizona. So happy to see you achieving more dreams. Oh, that's nice. Thank you. And you're welcome for taking you with us. I mean, heck, why not? You guys are more than supportive. I mean, I love this stuff. This is, I'm built for this. This is what I'm built for. Yes, that's the dumbbell. Yep, measure 27, Ronald. Oh, Daryl even told you. There you go. Okay, let's give this a shot. This one doesn't need a whole lot of time because it's so bright. So we'll say 15 seconds and start stacking it and see what we get. That is the Lagoon with all the material in it showing, for as we have this very high brightness on this side. So we're going to pull that down. Get it out of there. There it is. Okay. And this exposure looks like it might be good too. Let's
Interesting how we see only the very brightest parts of the red at this exposure.
I know it. But then again, my black level is way past the main curve. So I'm going to bring it back. So here we go. Curves are aligned, and now we're going to do this. We're going to align it. Now watch. Kaboom. Okay. So we can actually bring that right to our peak and dig in by pulling this curve here down. And we're only looking at a fraction of the data. But as you can see, we're seeing that bright blue white dwarf in the core here, right in there. That is, in fact, the stellar core. It's the corpse of a star. Donald Kunzer's with us. Hello there. Don't worry about it, Donald. I'm glad you're here. He said he's a half hour late. Don't worry, you don't need a pass for class. Now, if I was teaching astronomy class, then maybe we would worry about that, but we're not worried about it now. All right, so I've acquired 6 successfully and a 7th successfully. So see, going vertical, it's easier, it's better. You know, we don't get as many guide errors because of the wind. When it's a horizontal flag blown in the wind that's coming in, it's blowing into the barrel from that direction, so it's kind of pushing the scope up and down, and that's why we get these elongated stars vertically.
Izabela's here.
Izabela.
Hi, Izabela.
Thank you, Izabela, again for doing all that video work at our beginning where the universe is calling you. Rebecca Renfro-Borneman wrote that song. It's our SkyTour theme song for our whole show. It's really wonderful. She did a great job. And then Izabela took that song and composited it with a lot of our imagery And we ended up with just a stunning video from her. And then she animated our logo at the end, if you didn't see that. Okay, the telescope in the dome, and the telescope looks up, a meteor comes down, hits the moon. You know where she got that from?
Yeah.
Yeah, you do. Where did Izabela get that idea for the meteor to hit the moon? Who knows out there? I'm sure someone knows. In the chat. Somebody knows. Someone's got to know. Hey, Cindy Murphy. Yes, Cindy
I'll
says...
give you a hint. It was in 2019.
That's correct. Yeah. People will think of it. They'll get it. They'll remember.
They are.
Will they already say?
Oh, yeah.
Oh, good.
Some are chiming in.
Okay.
YouTube is doing something really annoying in their pop-out chat box. I have the chat set up on the right side of my screen, just outside the margin of your
Okay.
your
Screen.
display,
Yeah.
and they have put a heart
Oh, I know.
over
Right.
on the far right
Yes.
side
That's it.
that
I
I've
see it.
never seen before. And I either run into it by accident or it sits there and it looks like somebody is sending me hearts or I'm sending somebody hearts.
Well, it also blocks what someone just said.
Yes. I don't remember ever seeing that before.
I hope I could get rid of it because I'd like to get rid of it.
Yeah.
All right. All right. So let's see where it wants to be here, and you'll see a lot more detail. It's stuff outside here that's really interesting. So this star, fascinatingly, has expelled its outer layers and become what we call a planetary nebula. Now, what that means is that this star in here used to be a normal star, possibly kind of like the sun, maybe a little more massive, a little less massive. And when it used up its hydrogen, it swelled into a red giant. And then it contracted a little and then swelled more and then went back and forth, giving off what are called thermal pulses, you know. And when it does that, each pulse would send off a shell of material away from the star. And that's why we see all these little filaments in here. Okay, so this right here, you see that filament right there? That filament was originally in the star. It was part of the star's envelope. You know, the star here, its diameter was bigger than the white dwarf's diameter, which is only the size of the Earth, and yet we see it from, you know, like a couple thousand light years away. That's pretty bright and hot to be able to see that. And then this other material here, this stuff right here, right? If you look at this, this looks to be like the axis of the star right here, all right there, north south, and that this might be the equatorial part of the star. Now, it's possible that that's the north south and that these are jets that have been popped off from the star, but I actually think that there's different reasons for those north south jets we see. And those generally are like spikes. They're not broad bands that I've seen. And
I think it's precessing.
Well, we've talked about this, and I was going to just get to that. That say maybe this is a star that's actually doing this. And, you know, going around in a little circle like the Earth precesses around, like the Earth precesses. The Earth spins like a top. That's, you know, kind of like when the top runs out of energy, it starts to wobble. Well, this star could be doing that wobble. And that wobble could be, you know, if it's going this way, north and south, okay, that wobble could be like this axis is tipped this way as it's spinning like this, and then it's spinning like that, okay? So it could be going this way one time, and then over time it starts to do this, and maybe deposits this material out here in this whole ring. And we're looking at a snapshot in time, And maybe this right here and this right here happened at one point as well. That was a large burst that came off of the star. Now, I also have to say that could be the north-south region of the star, too. It could be that this is a jet from the north or south, and this is a jet from north or south. And because the star is precessing, it's making a continuous expulsion of material that forms a jet all along the north and south. There's a few papers on the Dumbbell Nebula that I have to read, because I think that's actually a pretty cool concept, and maybe we're actually seeing a north-south jet here, and that could be what that is. And if it's precessing, that could explain the shape.
Yeah, I have to guess that the two hot spots we see, top left and bottom right, that's where the jet is presently hitting the hardest.
Possibly, and that's why when we look at it, we see that it's actually ionizing the most material here.
Yeah.
So that's actually a possibility. And we have to keep in mind that stars do that kind of wobbling, okay? And so, but what would cause that? If a star is just spinning, then some kind of force would have to cause the star to start wobbling. And so usually it's going to be some type of unseen companion that's causing that, like another star that it's a binary within the system. But in this particular case, I haven't seen any indication that this particular star is a double star of any kind. So, don't know. But see, that's what we love about astronomy. It's a mystery. You know, that's the part that's great. It's mysterious.
I find it interesting and curious. The faint green line you see going all the way around gives it a vaguely eye shape.
Yeah.
That also appears to delineate the where the hot spots, the red is at upper left and lower right.
Yeah. Now these additional.
So is that like a bow shock or something?
Yeah, I know that this could be right here, for instance, that right there, and then another one out here. And if you look, there's another one right here. There's another one. In fact, to see that better, let's show you right here by pulling in our data. All right, and we'll just bring that out a little bit more. We'll overexpose the core, but now you can see that it's got some green stuff here and all the way out here. See that? That is pretty fascinating, because that tells us that this star has been thermal pulsing or pumping off material for quite some time. You know, and by bringing this down like this, we get to see the details inside of this area in here.
I mean, planetary nebulas are known for putting out shells.
Yes.
And that certainly looks like the eye-shaped line looks like a shell, and then up at the upper right, it looks like another shell, perhaps.
Yeah,
the
we
fainter
have
part outside that.
Yeah, we have one here. We have another one here. We have another one here. And this is consistent with our understanding of what happens in the late-stage stars when they reach the asymptotic giant branch, which is the second time they become a red giant. They start a thermal pulse mechanism where every, say, 10,000 years or so, they might send off another pulse. And that's not a hard and fast number. That's something that's, just what we've seen. So every 10,000 years, it might make a thermal pulse. So it takes some time for all this to happen. It's not just like it goes poof and like bleh, it's there. That's not what we see. All right. All right. Let's save this. All right. Right,
Donald Kunder asks, does Earth's axis wobble because of the moon?
The precession of the Earth was due to probably the impact that caused the moon to form.
The axial tilt, certainly.
For sure.
The moon orbits around Earth at a 5-degree angle to the plane of the ecliptic, where the sun and all the planets run across the sky.
Right.
So there is sort of an off-axis force there that might be influencing Earth's main precession. The Earth's axis does wobble somewhat. Generally, it's always the 23.4 or 23.5 degree axial tilt
That's right.
that the Earth's axis revolves around over the course of like 26,000 years.
Mm-hmm.
And that's why the pole star changes. That's why the Earth's axis, in effect, describes a great circle up in the sky of about twice Earth's axial inclination, or about 47 degrees. And that 47-degree circle, all the bright stars along that great circle up in the sky, it's called the ecliptic North Pole. That's why we see various stars come in and out as whatever's closest to the North Polar axis.
Mm-hmm.
So, like right now, Polaris is. I mean, I forget other stars that have been in the past or will be in the future, but
Thuban and Draco.
Yeah, there's charts out there that show you where that circle is in the sky.
Yep. Okay, let's bring up our night vision mode again. We are, as you can see, we're at 75% magnification on our sensor. I'm going to go down to 25. Okay, and now let's go from here. Let us go to another interesting location, which is fascinating. The other day we did this amazing view of a section of the Gamma Cygni Nebula, and that is the central star in Cygnus right here. Okay, it's called Sadr. That's the star. And let's check that out right now, and then after that we'll head to something else. First, I'm going to do this. Excuse me. Okay. Then Sadr. We're going to go to Sadr. All right. There it goes. Look at us go.
Mark, I think people are saying in chat, is your clock set on?
Oh, they're right. You're absolutely right. Thank you, guys. I'm going to fix that right now. In just a couple seconds, you're going to see that correct itself. And
I don't see it at all.
no, you don't. But there you go. It's corrected. I'm sorry, guys. I forgot to start that. I mentioned it to Daryl when we started, and I forgot to actually activate it. So now we're good.
It's Thursday now. Tomorrow's Friday the 13th.
Don't say that. No stream tomorrow. No stream tomorrow. Okay. And Cosmic Rays here. Making sure that we understand that, yes, Ray, we did figure that out. All right, I'll do this. Okay, so this is Sadr, and we're going to drop it down just a little bit. And I'll tell you why. Okay, then we'll move over to the east, because the nebula we want to see is literally here. It's quite a lovely nebula, and we loved looking at it. I used to not really find it too interesting, and then I had a whole new resurgence of exploring this nebula one time, and I was like, wow, there's really a lot going on here. This is the coolest nebula. So we're going to move over a little bit. And the other night we did a section of it that's a little further off of here. Okay. Okay, we'll let that settle out. Let it find its location. And from here, 25-second shot is more than enough for this guy. And we're waiting for ourselves to get our guide star. There we go. All right. We'll take a chance that it's... Oh, look at that. There's the wind. Just as I said that. To see how they changed the dashes? That was the wind. The telescope's a giant flag blowing in the wind, unfortunately. So we're waited out. Yeah, you see it's moving around pretty good. So it's 8:30 out there in the desert, and it's actually 11:30 here. So what we want to do is, you can see that the wind's blowing it because it's doing that. And of course it can't lock on a star when it moves that much. So I guess I could just try it and just go for it, right? See what we get. Alright, there's the Dumbbell Nebula. That's saved. That'll be up on the server very soon. Yeah, it's having trouble locking on because of the wind. Andromeda will be a good target, Ronald. Okay. That's the... that's the one I wanted to show you, but it's actually... I'm going to move... I'm going to move it in just a second. Okay, now... I'm going to move this down a little bit.
Michael H. says, you have to uncheck something in Live Studio.
What's Live Studio?
Part of YouTube, I assume. Ronald, the Whirlpool is down for the season. Pretty much.
And Michael, tell me what you're talking about in YouTube Studio. What do I have to do? What are you thinking?
He posted a link to a video that says how to turn off those signs over on the right.
Oh, okay.
Where I'm complaining about the heart. He says it's something in your Live Studio setting.
Thank you, Michael. I will check that out. Thank you very much. Okay, this is good.
I started it, but it's a 5-minute long video.
Okay, no problem. I know 5 minutes isn't a big deal, except when people are watching a screen. Okay, let's see here.
Sam, I have never seen that heart there before. I have my chat squeezed really narrow so it'll fit in over at the right margin of my screen, and it's putting the heart right where people are talking, and
It gets in the way.
Yes.
Okay.
And I don't remember ever seeing that before.
Yeah.
So it's all your fault.
It's my fault. I think you're right. And you know what? So is this. This is my fault too.
Yes, Ronald, the double cluster in Perseus is visible. Actually, we looked at it last stream, I think.
And we did. Yep. So Ronald wants to do Andromeda. He wants to do double cluster. That's it. Keep building your items, Ronald. And when you come in, we'll actually do it with you.
He calls it the jewel box. I thought the jewel box was down in Scorpious's tail.
Oh. Maybe. So this is the beautiful Gamma Cygni Nebula, and it's really pretty, and you'll notice there's some really remarkable dark nebulae in here. It's, again, this is what's called a diffuse nebula, powered by stars that are probably hiding in this inky blackness within the nebula. So when we look at this, when we see these long, wispy, or not wispy, but the long, general, broad areas of red, those are called diffuse nebula. Now, they are emitting light. They're clouds of hydrogen. The atoms are so far apart from each other that in a cubic centimeter, like a little tiny cubic centimeter, you might have between 30 of them and 30,000 potentially atoms. Keep in mind that in the air you have 10 to the 19th or more atoms per cubic centimeter in the air you breathe. So it tells you how rarefied, that is, or thin, these clouds really are. So you have a few atoms that are glowing inside a cubic centimeter, but when you add up the distance in light years, okay, like this, okay, then they collectively will glow in a way that you can see. You know, so that's pretty nice. Looks like our wind has slightly subsided. We've stacked 6 25-second shots so far. Let's zoom in on one of these sections here. Okay. I'm waiting for Starlink to come back. All right, let's see here. Okay, 1 second. We're gonna bring it back. Yeah, see, that's where I was. All right, and now got to take care of a little bit of housekeeping right here. Okay. So you can see how these beautiful dark nebulae now, they are dark enough. And this region here now, you can start to see that there's literally dark nebula sitting in front of a glowing cloud of hydrogen. This is all in front of, up here, in front of the cloud of glowing hydrogen, which is back here. So that's how this is outlined in space, right? We can actually probably bring that out a little bit more by doing this. There you go. So now you can see that with its tendrils. Now let's back out a little bit and let me do this one thing here. I'm going to actually kick it up so you can see what's really hiding back there. That's what's hiding back there. Okay, a lot of dark dust. This is all dark dust. And again, blocking this nebula, which is one big continuous nebula. It's not one section here, one section there. It's all one continuous nebula with a little dark dust dividing it to your eye. That's pretty cool. And now we're back to this view, the more proper view. And then we can actually work to bring out more detail. And we could take this guy here and move it over and start intercepting our curve to blacken the space and increase the contrast. Check it out. You know, look at this stuff. I mean, it is just outstanding. Kind of cool looking, isn't it, Daryl? I think Daryl's on mute.
I think you're right. Sorry. Michael H says, live stream dashboard. Click into your live stream video. Click edits, customization, reactions. Uncheck live reactions and then click save.
All right. I will do that on the next stream, Michael, I promise.
Yeah. I'll give you a link to the video if you want. It goes through all this.
Okay. All right, it color corrected, and you could see now that the black is actually a darker color. Look at that. Gamma Cygni Nebula. We've captured all the data we can get here, and it's actually relatively noise-free because we're capturing it at close to what's called unity gain, meaning that the optimum setting is 100 for the gain here on the right side up there, over here. Okay, but we're actually using 150, so a little bit more than we should. But I've taken things and images up to 350 gain, so it looks great. So what we'll do is we've saved this now. So if you go up to the server, this is the image you'll actually get. This will be up on the server shortly. There it is. That's the whole image you get right there. Beautiful. And you may download it for free and enjoy it. Put it on your desktop. Do all kinds of things with it. Take it dancing. You know, whatever. Whatever suits you. Okay. So that's the Gamma Cygni Nebula. Sadr is the star right there. Yeah. And now, let's now go back to our finder mode here, where we go into our night sky this way. We can zoom in a little more, and then go over to our planetarium. And from here, let's go right up to here. We haven't actually imaged this lately, which I think is kind of interesting. We're going to...
I'm sorry, Doc from Wyoming had a question. The stars that we see in the dust are closer than the nebula, correct? Yeah. The nebula is closer than, the dark dust you see, the dark cloud, is closer than the bright parts of the nebula, blocking our view where the dark clouds are.
Yeah, let's bring that back.
The stars are in front of that dark nebula, or some of them are just on this side of the nebula.
Yeah, and dust has a way in the universe, just like on Earth. And by the way, hi Doc from Wyoming. Dust from the atmosphere and the Earth will cause the sun to look red at sunset, right? And also the molecules scattering the blue light. That's why the sky's blue. Will make them, will make the sun look redder on the horizon. So that's what happens when sunlight or light of any kind goes through atmosphere particles. In this case, it's going through these little tiny micron-sized particles. And so if you look in here, you'll notice that some of these stars are very red. Now, yes, they could be what we call red dwarf stars. That is the most populous star in the entire universe. But they could also be embedded in that dust. So the dust could be reddening their light. It's probably a combination of the two. Right? But as Daryl said, if you're seeing them bright like this, it's likely that they're on this side of the dust, and the dust is sort of behind them, or they're very close to it, or not deeply embedded in the dust cloud like some of these other stars might be. Okay, so that's the buffer from the last exposure we had. Okay, so our remote connection system is suffering failures. So I have to constantly redo it, and they're gonna hear from me because that's not right. See, it's back. Okay. All right.
I lost your screen.
I know you did. Like I did before, I'm gonna bring you back. All right. Here we are. Okay. So again, this is Sadr, and we're going to move from Sadr. We're going to go up to the North American Nebula, because this is really an amazing location here. So we're going to go there. And this STLS telescope is right here. And we're going to bring it over here. You'll watch that little crosshair go right over to that star. It's getting there. All right. All right. So here we are. And I'm going to just do a 20-second shot to make sure that we're pretty close to that. I think we're close to where we want to be. I think it's right here, actually. So this might be good. It's going to show you more of the nebula and more of the material that sits in there. And that's really something else to see, if you haven't seen it before. You'll see hydrogen gas. You'll see dark dust. This is just a photo, right? And there we go. So I'm going to bring that down a little bit. Okay. Excellent.
Ray asks, how can one tell dust from dark space?
That's a very good question, actually. All right, let me drop this down. I'll answer that.
When you say dark space, do you mean empty space?
I think that's what he means. I'm sure that's what he means. Now, just because it's dark doesn't mean that it's not emitting some kind of light and also a spectrum that we can see. So we can look at dark dust and tell we're looking at dust versus empty space. In fact, when you're looking in the galaxy and through the galaxy, it's very rare that we don't have dust in our way somewhere along the way, especially where we're sitting in the galaxy. We're in the disk. And so we see less dust when we look north out of our galactic plane or south. We see more when we look in any other direction. Okay, so this is probably good.
Well, this may bring up the question of when people see what they might think is empty space, they'll call it a void, and there are very few voids in the galaxy.
Yeah, we do have the Bootes void, you know that.
Well, I mean, that's supercluster scale.
Yes, correct. Okay, so now we can clear this, and we have another shot coming in of the North American nebula region. This is going to be what we call the wall. Okay, look at that. Beautiful. Yes. So there's the wall. And again, in this one, you can clearly see the dust. In fact, in this one, the dust has a different coloration because it's actually being illuminated by some of the nearby stars. And so you can actually see that it's not just a blackness. It's actually kind of a brownish dust. We see that most especially in the Orion Nebula. The Orion Nebula, think of the Orion Nebula that we're going to be seeing in the coming weeks. Orion Nebula is an amazing nebula, but it's embedded in a molecular cloud of carbon molecules and other molecules, silicon molecules. And that embedded nature will make it so that when we look at Orion, we're going to see lots and lots of dust, except where the nebula is causing, or where the nebula is glowing, caused by stars inside the Orion Nebula, called the trapezium. Those 4 stars, we'll see those very, very clearly, and even better. Okay, so now let's do this. Let's pull this down just a little bit. Okay. Now, okay, in this area, for instance, if we zoom in on that, you can see the sweeping textures and the material. This is material sitting in front of what's behind it. And one of the things that we can see is starlight that gets a characteristic applied to it called extinction. So when we look at a spot where we think there's a void, if we see stars, we can tell if the starlight is being dimmed by something. And the starlight passing through those clouds will change the spectrum of the star, and we'll be able to see that change. And that change will tell us that there's something there, right? And there is so much more to say on that. But the bottom line is that we use the stars as the flashlights beaming through the dark nebula, dark dust, in order to sometimes see the dark dust. We don't need that here because we can clearly see the extent of this cloud. Look at that. I mean, this cloud goes for a great distance. And spectral analysis of this region can show us that the stars that are embedded in it are actually, sending their starlight through a cloud of dust. This is, in many ways, how we know what kind of dust we're looking at. And you also have to understand that there's radio emission coming from the galaxy and from other clouds, and that's going through dust as well. And that tells us what we're looking at. I know that's not a very good answer for those of you that want exactness, but that is probably the best global answer that one can get right now on this. I can talk about... Go ahead.
If you see dark areas, chances are they are dust clouds, okay, or dust and gas. There are very few real voids out there. One little example you touch on sometimes, Mark, is when you look at the Iris Nebula, I think it is.
Yes.
There's that very dark area, and you're actually seeing through to the other side.
That's right.
But
Yeah.
Otherwise, like in this image, if you see dark, it's dust and gas blocking your view of what's behind it.
Now, to Ray's point, when you don't have an IR system, infrared detector, infrared camera, how can you map this stuff? Well, that's where spectral analysis comes in. That's where gauging extinction of stars comes in. And that's where visual observation comes in. is it possible that we're looking at a really strange void in the gas right here? I guess theoretically, yes, but I don't. I know that when we look at things like this, knowing how our galaxy's laid out, we can map these dark areas and see the structure within them, and that tells us that they're sitting in front of things. Not only that, sometimes they are illuminated by other elements of the dust and gas that they sit within. Stars, for instance, can illuminate them, and you'll see them actually scattering starlight and forming a blue nebula around certain regions. And that blue nebula is, of course, what we call a reflection nebula. It's actually, I'm going to drop this down, and I am going to get rid of the telescope for now, so we can actually just see that. That's beautiful. Okay.
Mark, excuse me a moment, please.
Okay. Ronald says, what's the farthest object we can see from a land telescope? This has been the power scope, but okay, well, that's a very good question in this James Webb era, Ronald. Asking what's the farthest thing we can see. Visually, we can see with the largest telescopes, we can see visually several billion light years away. And with the James Webb, we can see all the way back to 13.6 or so billion light years away, and that's also 13.6 billion years in the past. We're seeing galaxies that have just sort of finished forming, which of course has thrown us for a loop, because we thought it would take galaxies several 100 million years, maybe 1 billion years, to fully form with their spiral arms and everything. So what we see with the James Webb has been perplexing, to say the least. James Webb looks at stuff like that, like these dust clouds up here, and we're going to see that when it looks at these things, now it's only infrared detector, of course, it sees way more stars than we see visually, because there's a lot more stars in here than meet the eye. Okay, and the eye sees only in the visual range. So if we can see beyond the visual range into the infrared, then we will see all of these things. And Ray is talking about how the North American Nebula and the Pelican is up there. It's way up here. And we could actually go check it out after this if you wanted to. Because I think we've actually got a few of these that are more than good enough. Okay, that's 19 shots right now. We'll go to 20. And then what we'll do is show you what else we can see to the upper right. So this is our current shot. This is where it wants to be. All right, and if we take us down to 25%, now you can see this over here is just the beginning of this next nebula that we're going to go check out. It's called the Pelican Nebula. All right, so this is the North American Nebula and its wall. Okay, so we'll save it and save it exactly as seen. Okay, all right, and now if I get out of that and take us back to our spotter shot, the night vision mode. Okay, there's our night vision mode. So what we're going to do is we're going to, first of all, let me also bring back my telescope here. And the telescope will be perfect. And we're going to just now head west. Look at all that wind. See what we missed? We missed that wind. That is so cool. Now the wind kicks in. We didn't want the wind to kick in before, did we? Okay. So now we're going to come down here and go north a little bit. And think we're actually going to go back to the east a little bit too, because I may have gone a little too far. Okay. I'll do a quick shot here. Oh, actually, let me go look here. Look at that wind.
Back.
Okay, cool.
Ronald asked a question. Did you answer it while I was gone?
I probably didn't. Ronald, what's your question again?
What is the farthest object we
yeah,
can
I
see
did.
from a land telescope?
I did. I told him we could see out, quite a few billion light years with a regular telescope, but go back to the beginning of time if we can actually use the James Webb. And that's the best option, really, for seeing back in time. Okay, I'm going to move us over just a little bit.
Ronald, and it's not so much the power, quote unquote, of the telescope, it's the light gathering ability.
Yes.
And this is where large professional observatory telescopes have it over us, is we're using 10 inches of aperture here, and they're using hundreds of inches of aperture. They see much fainter things than this telescope will ever see.
Yeah, there's... If we ever get an endowment, I can promise you all that the first thing we're going to do with it is get a massive instrument and use that. I'm just doing a 20-second shot to make sure that we're where we think we are. Right, here it comes. Yeah, there it is, right there. Okay. There's the North American. There's the Gulf of Mexico. We were down here looking at the wall. So I'll bring this down here just a little bit. Maybe just go a little bit to the left. And then we can actually...
I faintly see the pelican's eye and his beak
Yep.
and stuff there on the right.
Yeah, so what I'm going to do is I'm going to just move us to the west a little bit. Bring the Pelican in. Okay, that should be pretty good. Okay. So we're going to let it search, and then we're going to do another 25-second shot. All right, there we go. We are underway, and I'll bring up our stack. Our stack will showcase the last image we saw, which is the wall. Look at that, it's beautiful. Holy crap, that's just so nice. Yeah. All right, and we'll clear it and get ready for the Pelican. See how clear that looked? Notice how when this one comes in, you see how this stack shows a little bit of mottling, okay? There's like noise in there. Well, as we go forward here, you'll see less and less of that. All right, so why don't we just drop this right here?
I see the head of a raccoon peeking over the pelican's shoulder.
Go back at that. There we go. And now let's this is the pelican's shoulder. Is this the head of the raccoon?
No, his other shoulder. His, pelican's left. The pelican's right shoulder. The two bright stars are the eyes of the raccoon, and then the dimmer
This?
star. Yes.
Oh, because that's the eye you're saying.
Oh, that's the eye of the pelican, yes.
Yeah, okay.
The two bright stars in that dark cloud.
Yeah.
I mean, those are the raccoon's eyes. And that kind of upside down pear shape is his head.
Yeah, I got you.
Looks like a raccoon to me.
That's cool. Yeah, it's got the he's got the bandit eyes going on there. That's pretty cool.
That's correct, Ray. The last I heard, I think they say 2025. They were saying 2023, but then they moved it back a couple of years.
I actually applied to be the Vera Rubin Telescope astronomy outreach guy, but they already had other candidates, so I wasn't in the mix. That would have been pretty cool. Well, here's something that was lost to us. Look right here. That thin little dark line right there. That thin little dark tendril of dark nebula. Look at that. That's really cool. Let's bring the stack up for one moment just to do a color correction. Okay. Now let's do this. Brighten it up a bit. And darken the background space just a little bit more. There we go. There it is. Look at that, beautiful. So that's the pelican. See, there's the eye, and as Daryl was saying, here's the beak and the big scoopy mouth right here. Obviously, it's not really a pelican. You know, it's just what it is, right? Let's see what's happening here. Well, this is looking nice. We've got how many stacked here so far? 9 stacked so far. Not bad. Look at the detail in this, Daryl. See that right there? I think he's muted again.
Sorry.
Yeah,
Yes, I do.
look at that. That's beautiful. You know, there's so many supernovae have gone off, and so many red giants have expelled their atmosphere outward. The red giants make this dark dust. We have supergiants, which make this dark dust. Betelgeuse is certainly making this dust now. In fact, we've seen it, and it's actually partially caused Betelgeuse to dim over the last several years. And then it goes up and down. Betelgeuse is a variable as it is, because these big stars will pulsate anyway, and they grow larger in diameter than smaller in diameter, and they'll do a thermal event where they'll puff something off at some point, and that's what Betelgeuse is doing now. Look at that. Now we come up top here, and couched in this little corner here, we see this exceptional red. And you say, why is that so red? It's this red because this is an area where the dust is minimized. The rest of this cloud here, this is all hydrogen glowing in here, except for the black stuff. And in this region, the dust is actually, from our vantage point, reduced in intensity. There's not a lot of dust there. There's more here, so it mutes the red behind it. Okay.
I was always under the impression that edge of the pelican, the back of his head and his neck, is being lit up by something out of frame to the right.
Well, it's really a matter of how much dust is between us and that location. I think this location is red because there's not as much dust here as there is, say, here. This is the same glow. Why would this be redder? It would be redder only if there wasn't a lot of dust to mute this glow. And I think that's what we're seeing. I think we're seeing the muted glow here from all the rest of this. I mean, it looks like that right? But then again, I do believe that this is just a region where the dust is thinner.
I think it's like when we see the wall behind the Horsehead in Orion.
Hmm.
It's lit up by Sigma Orionis.
Right, and the reason that the wall looks like the wall is because the dark dust mixes with that hydrogen H2 region, that glowing gas, all right, and it mutes it after the wall where the dust abruptly seems to taper off. That's sort of the edge of that molecular cloud location. So it tapers off at that point, so we see that bright dividing line. I think it's the same thing we're seeing here, is because there's less dust at that point. And actually, the Horsehead kind of makes that point, I think. That's my thoughts, anyway. I'd be happy to entertain other ideas, like you just said, but
Well, we've talked about that before. I mean, the wall, the brightest part, it's a line shape behind the Horsehead. It's obviously being illuminated by a Sigma Orionis.
correct. But Sigma Orionis isn't just illuminating that; it's also illuminating what's beyond it. There's no reason for it to just stop there. And the fact that it's straight is part of the problem. If it was curved, such that it would illuminate, Sigma Orionis would illuminate a curved area around itself, that would actually be expected. It wouldn't be expected that it would be a straight line. So it's illuminating that straight line, it's causing that straight line to glow, and everything past it to some extent, to its ionization distance. That's how I read Sigma Orionis.
Anyway,
Well, I'm sorry you don't like that, but that's what I think. Here, we'll brighten this up, Daryl.
I think your images have a more muted look since you started turning the gain down.
That might be true. I mean, I also have this parameter down. If I bring it way up, okay, we can do that. See how much brighter it looks? See, the colors are less muted now. But because what we're doing is this line here, if we bring this down, we can turn this into a black and white image. Like we used to take with Tri-X when we were younger. But now I only had it to about like here. But if we go all the way up to almost to the top, then you see that it does have that color. I just don't want to make it so gaudy that we start to get these areas over here that will look too red, and then sometimes the pixels don't know what to do when they're too red, and it makes a strange artifact. I don't want artifacts. Just why I do things that way. Look at that. Isn't that pretty? Look at that. You can follow the trail of this. This was not visible to us in the other camera. This was not visible. Look at that little line. That wasn't visible to us. Getting a lot more detail. These little ribbons, look at those. These ribbons here and here and here. That's really interesting. Let's dock this back up. That's really pretty. Now, see what else is there. We can actually punch this up and see how much more details there. You can see a lot more of it here. But that's really kind of too bright. Does that look better? Daryl?
Oh, you're asking me?
Yeah.
Somewhat, yes.
Yeah. So I increased it.
I think there may be a trade-off between your gain and making things easily visible for the audience.
Well, I mean, that could be true. But little details like this wouldn't be visible with the higher gain, would they? Those would be lost in the noise of those higher values, and only after we applied noise reduction later in processing would those show up. So I'm just running the camera to where the specifications say you should, and I'm 50 over what they say is the best. And I used to do 300, remember?
Yes.
Yeah, the 294 MC Pro.
Well, I know you changed since that guy said this to you the other night.
Well, yeah, I mean, I looked up unity gain and figured out what it was for our camera, and it's 100. And unity gain is the point where you have the least amount of noise, and thus the largest amount of detail in the smallest areas will show up at that point. And sure enough, if you look up here, we do see a lot of that detail that just wasn't available to us before. And what we can do in processing is we can actually push this, okay, like this, and get it to look much brighter and still have our detail. And if we did that with a 300 gain, this would also push the noise much louder, and that would be a real problem. So I think this might be the best trade-off. But you might be right. Maybe we are sacrificing a little bit, but we're seeing details we could never see before. This little guy right here, that little guy would probably get almost lost in the noise. You know, that's my guess. Look at that, all that detail. See that? That is so cool. Yep. And these are star images that are actually subject to wind, but the compiled version, this total overall view is just beautiful. And you can see a lot of those red stars that I think you were mentioning those before, Daryl. Many of those red stars are M-type stars, M-class red low-temperature stars. But a great deal of them are also going to be buried in this cloud and suffering extinction of their light. All right? So you'll notice that when you look in this cloud, you don't see the same number of faint red stars in here. That's because their light has been shunted almost entirely. But here, where it's mostly gas and not a whole lot of dust, you see that what dust there is causing the light to be reddened, as well.
There is an object from the center of the screen about halfway to the right-hand edge.
This guy?
That fan shape right there.
I saw that. That's pretty interesting.
Can you close in on that a little?
Yeah, maybe I can. Let's see what we can do here. Again, I've never seen that before. So let's do this, and now let's actually operate on the data a little bit and try to bring that out. I'm just a little bit...
That helps give all that a three-dimensional look with the dark edges over on the left.
Yeah. So there you see that. Now you might be able to do this.
Looks like a teepee.
It does, doesn't it? Let's open this up a little bit. Okay, now you can see that there's a spire of dark nebula in here, and another up here, and this one kind of goes up here. This looks like part of the same dark nebula complex, this is a little area where there is more emission than over here, or it's hidden by the dark nebula or whatever. But this is a very fascinating little piece. We've never seen this before. This is a new thing for us.
Right.
What I'd like to do is use the data and go see if this feature is there exactly like this. Most likely it is. But I'd like to see if we can catch it with the other camera. So this camera view, seeing all this faint stuff, is something new for us. We've never seen this kind of faint material here before. We've seen the dust, yes, but we haven't seen the detail in these dust clouds like right here. This one's actually like two branches of the same cloud, two branches. That's cool. And let's put it where it wants to be again. Look at that. Wow. Very cool. All right. We'll save this, and I'll zoom out now just to bring it back to where you want to be. I'll bring back the telescope here. There we go. And now pull out this to here and kind of give you a last view of the bright nebula, the bright part. And this here, this up there on the upper right, gives us an idea of what's really there. It overdoes things, and it kind of really pushes things beyond what they should be. But they are quite nice. But that's just incredible. Wow. All right. Cool. Let's call this Pelican, because it is Pelican Nebula. All right, it's ideally the Pelican now, just a Pelican. So we can save that. And then save it exactly as seen. And that will be right up there for everybody to grab. All right, let's see. We have time for some more. I'm going to try that, because you mentioned it before. Let's see. Yeah. Okay, let me get rid of this. Okay, the Iris Nebula is quite high in the sky. Would you like to see the iris?
Sure.
All right. Okay, we save this, so we're going to pop out, reset our scope back to its hunter-killer mode here. And let's bring this up. All right. Now, when Daryl was mentioning the iris before, he was saying how there's a certain segment of the iris where we can actually kind of see through the dust. And we are going to look at that right now. You'll see that exactly. So, telescope is going to wander. There she goes.
I thought the point was it's that we're not looking at dust. We're looking at an actual
hole.
Yes, a hole.
Yep.
That we're seeing through to the far side of the nebula.
That is correct, and exactly what it is. Let's is that it? Let me increase the gain enough to see that. Yeah, that's it right there. Okay. So we shall bring that back. We're going to head westward. All right. Bring this up. Okay. We're getting nailed by some wind, but, you know, we'll see what we can do here. Okay. We'll center it up pretty much. There's a piece out here that would be nice to see. So we could see that by going west a little bit. And put it right about there in the frame. And then we'll see there's a interesting brownish nebula. This nebula in particular that's surrounding this, you can't tell it's got a nebula yet. But I think it's right about here. So this might work. So we'll let that hunt down a star. What you end up seeing here is that the dust is actually illuminated by the star, and it's also scattering it's also scattering the star's light that's in here. So there's like a bluish nebula in here, and then the dust around here is being illuminated by other stars nearby. And so the dust, you can see its native color, and it's actually brown. So now that I've gone and said all that, let's show you. And this will be a make this a 25-second shot, and I'll bring the gain down to 200 instead of 150. So we'll be about 100 higher than we ought to be natively, but that'll allow us to catch some of the fainter dust rather quickly. Okay, so 25 seconds, off we go. And it's gonna be that star. That was our beautiful last footage in Pelican. Very nice. And over there, look at that. It's like a bent fork. That's cool. There's so much to see in these images. Okay, so this is our first iris shot. Okay, obviously we got hit by wind. Yeah, it's still being hit by wind. Let's see if this will give us a better one. I'm clearing it. I'd like you to see what it actually looks like. Yes.
The Ray's spider web is really dancing around.
Yeah. By the way, Ray, we named the spider Ray after you. Okay, I gotta clear it again because I want a round. I would like round stars. At least to start. And it's at 3. Yeah, this is a particularly troublesome spot because the wind is really blowing on it. And it's trying to keep up. Let's see how it looks. Oh boy.
Starlock's really jumping around.
It is. Alright, so let's one more time. And if this one is reasonable, we'll let it continue. I haven't even named it yet. Okay, well, we'll let it continue for the time being. I'll even name it in case we decide to save it. Wow, 5.3, that's a lot. These are going to be pretty elongated. Wow. You can start to see how the stars back here seem like they're hidden. There's a reason for that, and that is because they are. They're being hidden by a cloud of dust that's here. It's actually all throughout this region. Yeah, this is quite something. You can start to see the void now that we were just talking about with you earlier, that you can sort of see stars behind the cloud through. Okay, that's right here. This is the cloud. All right, this is the dust cloud. And here is an opening, like a little keyhole that you can see through to the stars beyond. By the way, Mr. Django, I didn't say hi. Sorry. Yeah, stars are awful on this because of the wind. But that happens. I don't know, Daryl. I'm not sure we're going to be able to keep any here. I mean, you can see them, but this is really supposed to be a very sharp delineation in here.
Yeah.
And it's not.
And those stars in the lower right are really
Yeah, you can
getting
see.
Stretched.
Yeah. All right, guys, I'm going to abort that. Sorry. We'll come back when we have less wind at some point. I was thinking we can do one that everybody likes. Okay. And let's see how it works. Might be quite nice. Let's go up here. Over here. Okay. No, I'm not gonna do that. I was thinking at first about the cocoon, and I realized no, that's gonna be the same problem as this. But we could try this. That's in fairly good positioning, you know. It's like over 60 degrees in altitude, so that's pretty good. And it's facing another direction, so that might actually be good for us wind-wise. See where the telescope's going now? Yeah. We are heading to the Andromeda Galaxy. Ronald, this will give you an idea of what you can expect. Here it is. That's what you get. Now it's big, and so it goes way outside our field now. So what we're going to do is I'm going to move it. And we got lots of wind, holy cow. Wow. I'm not even going to get a motion here. Oh, this is... Holy cow, that's even worse. Well, the wind is... This is why we have limitations on our wind. Because we won't be able to do anything if the wind... Look at how bad that is. Holy cow. I'm not doing that. Telescope's being blown around. Well, maybe Ronald isn't going to get a taste of what the Andromeda Galaxy will look like for him. Let's see if we can... Well, actually... Okay. Maybe we can do the double cluster. Yeah, we'll go to the double cluster. You should see the double cluster show up really nicely here. There it is. Okay. And let's see if we can actually get a photograph of it. I'm going to drop it down now and go up north. Okay, let's yeah, we're getting some motion, but let's try a 15-second shot, because see, just I say that. All right, let's try that. Yeah, Ray, I understand the pros and cons of the clamshell. But what I can do, I can mitigate that. I've got some ideas. Let's see how this looks. Movement. Let me clear that. Let's see what we get. These numbers, if they go above 2 on either side, that's going to show some motion. Like this is supposed to be a round red giant star. Yeah, 2.3 on the left, 2.3 on the right, 2.3 there. Searching, lost track because I couldn't do it. Yep. This is what happens.
An old saying comes to mind.
What's that?
Something in the wind.
I think I know the saying. Okay, so we're gonna just want to get one good shot. It's not the best, but that's a little better.
Ray, not necessarily.
What do you say?
Is a German equatorial mount better in the wind? Fork mounts tend to be stable. It's the mass and the size, the length of the telescope as much as anything. Basically, like how much of a sail it's presenting to the wind, you know?
And if you look here, it's quite a sail here. You know, it's the body of the telescope plus this additional element of the dew shield. This telescope right here that you see right there, that little telescope, that's mounted on the back of it. That's the guiding scope, and that's actually guiding the whole telescope. And let's see. I'm trying to figure out where we are. 4.6 point. That's no good. I paused this because I don't want to.
Yeah. I just looked on Windy at the observatory's approximate location, and the wind is out of the north there.
Yeah, which is why it's catching inside the barrel of the scope. Okay. Well, this is where we're gonna end it, because this is probably not a good idea to keep presenting a windy front end to our telescope. But
not a bad picture, though.
No, I saved it. I did save it. Okay, so There we go. All right, so what we'll do, since this is a part you rarely get to see, since we're going to call it for tonight on this, I will allow you to show you actually what we're doing here. And let me, there goes that. Okay, so the telescope is in its building. Here it is. Okay. And one thing I got to do before we do this is I'm going to increase our speed by a substantial amount just for the moment. And then I'm going to bring us back toward the west. Like that. You can see the telescope moving in there. I gotta set up a location here that the telescope may need again. So we'll do that. So you can see what's going on here. Take it out of the wind. There we go. Then we'll head to the west with it a little bit. All right. And then I'm just aligning it, getting it ready for closure. Okay, so now that I've done that, I am going to take us up to the menus and move us up to, oops, I went the wrong way. One second. Here. Well, anyway, so there we go. I know that we haven't, I gotta do a setup, sorry. We haven't actually done like a final object, but the wind has kind of ruined our attempts for tonight, unfortunately. So I'm going to zip us down. Okay, lower limit and go up again. And the park position a little bit lower. There we go. The park position will be right here. And we'll use current. There we go. All right, so now what that means is that when the telescope is fully able to move around, we can go up in the sky anywhere we want. And then when we go to park the telescope, it's going to go to a predetermined spot to shut down. And that is going to be at this next location. There it is. It's moving to our park position. And you watch here, it'll say slewing the scope. And it'll say it is done parking and turn the scope off. So my control program here that I wrote with Arduino, okay, is this program here. Okay. And this is the control system that I did for the observatory. So now from here, we just do a simple shut off. It goes off, the camera goes off, and then we can get rid of the objects that we have on there. Now, what we do next is we come in here, and this is our shutdown procedure. And then let me just pull this out a little for you. All right, and now from here, we just instruct it to shut the roof. And there we go. 2,500 miles away, the roof is closing on the building. That little square thing up there that you see, that's a solar fan vent. So if it gets above 120 degrees in there, that kicks on and exhausts the hot air out of the roof. And there we go.
Pretty dinky fan.
Works though. That's all you need. Okay. Scope is
Good night,
disconnected.
everybody.
Thanks for coming out, guys, and we will definitely be back when we have a clear night and windless night. Tonight was supposed to be pretty good, but I knew we were possibly going to have a problem. So we're good. Anyway, have a good night, guys, and we will talk to you very soon. And Daryl just said good night to everybody, so I got to say good night too. Good night, everybody.
Good night.
Okay. Thanks again for coming. Bye-bye.